Those are like famous last words, by the way. I was told I have till 9 p.m. I'm not sure if that's today or next week, so I'll see how long I can go here. So this talk is API First Design with RAML Plus, and this is actually a talk that combines a couple different talks just because I had the time, and I wanted to harass you guys as much as possible tonight. Really what this talk is about, first and foremost, is changing our mentality. We're going to talk about methodology in regards to API design. We're going to talk about something called RAML, which is the RESTful API modeling language. But we're not going to go into depth into overall best practices. We're going to cover some of them. We're going to talk about what is this HDS thing. We're going to talk about designing your resources. But we're not going to go super, super in depth. Also, this isn't an API first application design talk. So if you're saying, hey, I want to build APIs to separate my application, or I want to build SOA services to separate my applications, that's not what we're focusing on here. And the promise I make for every talk is this talk will be awesome. Maybe. We'll find out. Most importantly with this talk, I'm going to try to keep it to an hour and a half. I'll do my best here, maybe less. There's a lot on this topic, and there's no way I can squeeze everything in this topic, nor would you want me to. So when we go to the talk, please check out raml.org. I have a link for my book, which I recommend checking out as well because I'm a shameless self-promoter. Which brings me to my next slide. Who am I? I'm an API fanatic. The reason I give this talk is not because I have some amazing wealth of knowledge, because I don't. I mean, this stuff's out there on the web. You can find most of this yourself. The reason I give this talk is because I've built APIs, and I've had tons of frustrations. I've used APIs, and I've had tons of frustrations. And so this talk is more geared towards how do we make sure we build APIs that don't suck. But I couldn't use that title because it was already taken. I have to apologize because I forgot to bring in a copy with me, but I have a book out there called Undisturbed Rest. I'll have a link for everybody to download this book free of charge, but if you want a hard copy, just shoot me an email and I'll get you a hard copy as well. Last but not least, the Dev Relations Manager at MuleSoft thing. I want to give MuleSoft a big thank you because this is actually my job to go out here and talk about API best practices design and really try to give back to the developer community, and they make that possible. By the way, if anybody's looking for a job, we are always hiring. Not to do again a shameless plug, but I'm going to. So with that, I'm going to stop talking about me and MuleSoft and get right into the talk. And I want to take you guys on a trip. I want you to imagine that we're going to build a city with Legos. And you're going to build like a super nice city. We're not going to build like a cheap city. We're going all out. We're going to have a fire department. We're going to have a police department, a park, you name it. We're going to have this beautiful city. By the way, you know what city this is, right? This is gorgeous Oakland. And you can tell it's Oakland because if you look at the bank right there, you notice it's being robbed. This is a joke I can't tell in Oakland, apparently. Disclaimer, I'm from the area. I love this joke here. I'm sorry. So anyways, you said, well, build this beautiful city, and you start building brick by brick, piece by piece. There's just one little problem. You don't have the instructions. You don't have the specs that say, this is where these bricks go. This is how you make this building. So no big deal. I mean, we're all very intelligent beings here, so we start doing the best we can. You know, we're going to put a brick there, and every now and then you put a brick in, it just doesn't fit. So you say, you know what, no, this isn't right. I'm just going to change it. Not a big deal. Until you finally have the most beautiful city, which I spent hours on, and it looks exactly like what you planned. This is my actual city. Now, this doesn't look like the original city, does it? This doesn't have the nice fire department, the nice park. But this is exactly how we build APIs today. We say, I don't really know how to build it, but I know what I want to build. So I'm going to put this piece here and put this piece here, and I'll change it until I get there. The problem is, we're not very good at short-term design. And I'm going to prove this. How many people here think you're good at long-term design? Okay, you're not, and here's why. How many people here have ever written code? 3 people. Okay, 4 people. Oh, perfect. Okay, well, I can feel the excitement in the room. They're like, oh man, another hour of this guy talking? How many people have ever written your code, and you look at it a year later, you look at that code and you go, this is the best code in the world, right? No, you look at that code and go, what was I thinking? How many people have ever started extending a class, and then you extend the class, and you extend the class, and you're like, crap, I'm stuck. I have a problem, I have a conflict. See, because we're very good at knowing what we need to do in the short term. But we don't always think about what we don't need to do or what may be in the long term. First of all, when you version an API, you create backwards incompatibilities. In other words, whoever's using your old API can't use the new API. The second problem is that means you have multiple services to maintain. Now, prior to MuleSoft, I worked as a developer evangelist. And at the company, we launched a new version of our API. My job, like the main function of my job, was to get people to upgrade from version 1 to version 2. And in that year, I think I got 4 people out of the thousands of people using our API to upgrade. Very well says developers, we're hubry, we're lazy, and we're impatient. And what it means by that is we don't want to have to maintain things when we can build things. We don't want to have to go back and start changing the stuff we've already done if we could be creating new features. And that's very true. Developers are not going to upgrade their API just because, which means you have multiple systems to support. It creates confusion among developers. With these systems you have to support, one of my favorite calls, got a call and the guy said, hey, I have a problem with your API. I'm like, no problem. Which version of our API are you using? Well, yours. Okay, well, how does it work? Like, what type of requests and stuff are you making? Oh, well, I make a post request to your API. Okay. Do you get back JSON, XML? Yes. Now, I don't know if this speaks to me or to the individual. It took me 30 minutes to figure out which version of our API he was using. And it turned out he was using our old version and wanted to do something with the new version that the old version didn't support. And developer adoption, again, nearly impossible. They're not going to upgrade. They're not going to change. Here's what's going to happen. You're going to send an email saying, we have a new version. You have a year to move to this new version. And then 3 months from that, you're going to say, hey, you haven't upgraded yet. You have 3 months to move this new version. And in the week, you need to move this new version. The last day, we are cutting off the old version. You have to move. And the day of, you will get 50,000 emails going, how could you do this? Why are you doing this to us? You'll see complaints online, and it'll hurt your company's reputation. It's very, very important to realize that your API is a contract. Your API is your word, your company's word to developers. Let me ask you a question. How many people here have used a giant social media API? I can't say the name because they'll sue me, but it starts with an F and ends with a book. Anybody? Have you ever had that change? And I gave one talk, and we had to censor what one of the audience members said about the API changing. When it changes, it stops you from being able to work on functions. It stops you in your tracks. You have to go back, fix the API, and you're not really thinking good things about them at that point. Here's the thing about versioning. Versioning is a necessary evil. It is very, very important to plan for it. But it's also very important to try to avoid it and to go with the mindset that we're not going to break backwards compatibility, that your API is going to last 3 to 5 years without having to version it. Think about it, 3 to 5 years without having to create a new version of your API. So when to version, because again, you will have to do it eventually, you have backwards incompatible platform changes. For example, your platform used to have a calendar, and now the calendar is completely different. It makes sense in that case to change the API to work with your new platform. Your API is no longer extendable. This is what we're trying to avoid. This is my API went as far as I can, I add new features, it doesn't support them, I'm screwed. Or your spec is out to date. You want to have a REST API and you currently support SOAP, so you need to redo the API. Again, something we're trying to avoid. But you should not version your API just because you added new endpoints or new resources. You shouldn't change it or version it just because you added new data. You shouldn't have to version your API for changing your technology stack. If you go from Java to PHP, which is the worst thing I could possibly say at this meetup, you should not have to change your API. The interface should stay the same. The people using your API shouldn't care what technology you're using. You change your application services, you change the code, or you change a service provider. That should not affect the interface that your developers experience. It should be decoupled from that. So versioning is a necessary evil. It's something that we should try to avoid, but something that we should be aware of. But we need to make sure that our application is decoupled from our technology stack, because versioning doesn't excuse poor design. And it needs to be thought out enough that it remains extensible, not just for the current roadmap, This is the other mistake we make when building APIs. We say, what is our current roadmap? What do we need to do? That's great, but what does your application need to do in a year or 2 or 3? What's your platform going to look like in 3 years? How many people have a roadmap for 3 years? Nobody knows. Which means just like building that class for your application and saying this class has to be extendable and flexible enough to do whatever we need to do, you want to build your API in the same manner. Again, versioning does not excuse poor design. And just because I need a quote for that, there's no substitute for good design. When I say there's no substitute for good design, I'm going to tell you a story a little bit here. You can have the perfect code. You can have the perfect API, but if it's designed poorly, it doesn't do you any good. Now, one of the challenges we have is before we can design an API and jump into using tools like RAML, we have to know what it is we're designing. If you think about it, when we build an application, we don't just say, I'm going to create a photo website for somebody, put it together and say, here's your site. We don't do that. We get their feedback. We involve them right away. So the first question is, who's going to be using your API? What's the purpose of your API? What type of API are you building? And more importantly, why? How are you going to maintain your API? Do you have a plan to follow up with that? How are you going to document your API? How are you going to let users interact with your API? What about authentication, provisioning, throttling? How are you going to manage support? And by the way, the support one may be super easy. You could say, we're not going to offer support. Or we're going to have a community forum. Or it could be as advanced as saying we're going to have an API support team. But you should have an idea because developers are going to email you and say, how do I get help? And you need a response for that. So who's going to be using your API? Is it going to be your current customers? Is it going to be business partners? Is it going to be third-party services? What actions do they need access to? What do they want to do? One of the most common responses I get when people say, we want to build an API, and I say, why? Is they, we want to expose our data and services to our customers. That's not a good answer. It's a great talking point, but what are they going to do with that data? What are they going to do with those services? This means talking to them, including them from day one. How are you going to involve them in the design process? Again, if somebody hires you to make a photography website, you don't build the site for them. You say, okay, well, what are you looking for? What type of photos? What colors do you want? What design do you want? We need to be incorporating this from the get-go. List out why. Again, access to data is not good enough. What is the specific purpose of your API? And the reason you want to involve the users right away is because they may tell you you're wrong. Now that sounds silly, but I had the privilege of contracting on API. We worked on this API for 6 months. And the code was perfect, I know, because I wrote it. I don't know why people laugh at that, but they do every time. It kind of hurts my feelings. So we had this API that hits all the best practices. The code is good, it's extensible, it adheres to REST, beautiful thing. And we put it out there, and 3 weeks later we realized something. Nobody was using it. Now, it wasn't because of the code, it wasn't because of the design, it's because it didn't meet their needs. We spent 6 months building a product that nobody had any reason to use. We then spent 3 months trying to save this, which every company does, by the way. Oh, we screwed up, let's fix it. Spent 3 months, and we could not salvage it. In other words, we wasted 10 months on a project. Think about the cost, the time involved, when if we had taken a week up front and said, what do you want? We would have saved ourselves all that hassle and had a solution that they did want. Explain how your API is going to interact with existing services. If this is an internal API, how's it going to be used internally? If it's meant to work with HR, how does it work with HR? How does it work with the Workday or Salesforce, whatever solutions you're using? List out the actions the API needs to be able to handle. And this is for developers here. These last 2 ones are very, very important. Do only what is necessary. When you're building an API, you're building the foundation of a house. You're building the foundation. And the fancier you get with the foundation, the less you can build on it. Because if you try to get fancy, if you try to say, I'm going to create this shiny, amazing API, first of all, it's not going to be assembled. Second of all, developers can't use it. Developers want a simple API that we can use without thinking about it. And more important to me than, oh, it has all these bells and whistles and there's a unicorn that comes out at this endpoint, is that it works and it doesn't break. Now, when you list out the actions, what users need to be able to do, what I really recommend doing is setting aside the whole CRUD aspect. We always say, create, read, update, what are the HTTP methods? Push that aside. Don't even go to that point first. Instead say, okay, they want to be able to edit users. They want to be able to create users, get usernames, passwords. They want to be able to send messages, create a draft, send a draft, delete a draft, get a message, mark a message as read. For products, they want to be able to view a product or add to the cart. For a cart, they want to be able to check out. Now, this seems very, very basic, but this is going to serve us in a lot of different ways. First of all, we can see exactly what our customers or users want to do with the API. Secondly, we can organize our API in such a fashion that it makes sense. For example, you'll notice I have message a user and send a message. Two different actions that are nearly identical in two different places. I don't need them in two different places, but I can say, you know what? It makes more sense to be in the messages resource here, but when I build up my users resource, it probably makes sense to have a link in my response to that. So rather than have to later build out this advanced hypertext linking map, we already know what our hypertext links are. Here's my favorite question. What type of API are you building? Are you building REST, partial REST, SOAP, RPC? Let me ask you a question. Should you build a SOAP API? So I've got a no, I've got a yes. And the answer is it depends on your customers. At MuleSoft, we work with a lot of legacy systems, a lot of old companies that are used to using SOAP and used to working with XML. Now, if they're building an API that needs to work with their systems and for their customers that are still using SOAP, as much as it pains me to say this, it may make sense for them to build a SOAP API. Now, if they're saying, look, we want to be cutting edge, we want to have an API that's super easy to use, we just want to use the get post methods, they probably want to go with an RPC API. Or if they say, look, we want a long-lived, extendable API that takes full advantage of all the HTTP methods, REST API. But why are you building the API in that format? It's very, very important before you build something in a format to understand why you're choosing that format. What does that mean for development? What's it mean for usability? RPC APIs are very easy to use. SOAP, not so much. REST, a little bit tougher. What does it mean for longevity? RPC, very quick to get out the door and very quick to die. REST, a lot more work, a lot more planning. It's going to be a lot more flexible. And with each type of API that we look at, there are strengths and weaknesses. So do you understand those strengths and weaknesses? Again, we want you to be successful. I don't care what type of API you build. I want you to build an API that meets your needs. If you're going to say, look, no, we are stuck. We're going with REST. REST is what everybody's talking about. Do you understand what REST is? REST is not an API. REST is a design theory. It's made of 6 constraints. It's client-server, meaning that the client and server should be able to evolve separately. I can change things on my mobile app without changing things on the server. It's stateless. One of the key things to REST is you do not store state on the server side. You can store state on the client side. You can keep track on the client side. But because it's stateless, every single call has all the information necessary for the server to interpret it and understand it. Now, if you're doing high banking transactions, you may say, look, I don't know if I want to rely on this aspect alone. Again, depending on your needs. Cacheable, it has to be cacheable on the client end. We all say we're going to implement cache services in our architecture. That's great, but REST determines that you have to tell the client, can they cache a response, yes or no? How long can they save that response for? A uniform interface. In other words, when I talk to your API, the interface shouldn't change. If I talk in JSON, I should get a JSON response back. If you change anything on your architecture, shouldn't matter. Everything's nice and clean and doesn't change that way. Layered system. It's made of multiple components. How many people have heard the term microservices? That's the big buzzword right now, microservices. That's essentially what a layered system is you have different services working together. With the API, you can pull pieces out of your API without breaking the whole thing. You can replace things. And then code on demand, which is exactly what it sounds like. It was originally determined to be like Java applets or servlets, but now that's expanded far beyond that. But do you want to provide code to your users when they make calls so they don't have to write the code themselves? Now, to be very fair, there's a lot of security concerns with that. There's a lot of complexity with that, especially since the web has evolved to multiple languages, which is why that's the only optional constraint of REST. And as we talk about REST, by the way, keep in mind most APIs are not RESTful. Dr. Roy Fielding, the creator of REST, was a little frustrated one day when he basically came out and said, what has to be done to show that hypermedia is a constraint of REST? And hypermedia follows under the uniform interface constraint. He goes, is there a broken manual? What's wrong? Because most people don't use hypermedia in their APIs. Now, does that mean you have to build a REST API and it has to have hypermedia and it has to adhere to all these constraints? Absolutely not. I'm a huge REST fan. I think it's the way to go, but that doesn't mean that's the right solution for you. But it's important to understand if you're not adhering to the REST constraints, why? Why are you not adhering to those? If you are, why are you? Yes, sir?
Can we go into a little bit more detail into what hypermedia really means?
Yeah, yep. So I'm going to talk about hypermedia in a little bit here later. But essentially, hypermedia, it's something that kind of scares us to a certain degree because we hear about the term in APIs. The term was actually coined back in 1965 by Ted Nelson. And it's something we use every single day. If you use the internet and you pull up a web page, that's the hypertext markup language. That's actually hypermedia when you're watching videos, when you're listening to audio. So in the API, what it's really talking about specifically is some form of hypertext linking. So just like when you go to a web page and you have links that you click on that give you more information, the API would provide you links with the available actions that you can do. So that's in a nutshell. We'll talk about more. Again, you have to understand why you're choosing the way you're building your API and what format you're using. There is no right and wrong answer because it meets your needs and your situation. You know, you can build a wonderful REST API, but again, if you're spending hundreds of thousands of dollars and all you need to do is spend a couple thousand to build a quick RPC API to meet your needs, probably wasn't worth it. On the flip side, if you need an API that's going to last 3 to 5 years, you probably want to make that investment into REST. How are you going to maintain your API? You know, your API is a living document. It needs to crash my computer, apparently. No, let's skip this and update for now. Thank you. Computer's so helpful. It's like, hey, you're doing a presentation. Why not? But that means that once you build your API, you have to maintain it. When you add new features to your platform, developers are going to want those new features. When you make changes, they're going to have those changes. If you add more data, they're going to have access to that data. Also, you utilize something called spec-driven development, which we'll talk about. And that means your API should be defined outside of the code. Now, we as developers, we like taking shortcuts. We like saying, look, I can write the comments and generate my documentation from the comments, and I can just build the API as I go. The problem is, once you start doing that, you're building a house without a blueprint. Now think about that. Imagine if they tried to build this building. They said, we're going to put a wall here and a window here, and we'll move this over here. And eventually, you'd all be staring out at a brick wall. Wouldn't be designed very well. Because again, we're very, very good at short-term design. We're very good at accomplishing what we need to accomplish in the moment. We're not good at long-term design. And that means if we make these changes in the code, if we make these changes without testing them, we're setting ourselves up for failure. Your spec should define the schemas and design patterns. Your API should be uniform. It should be consistent in how people use it. And then your code should be written to match the spec, which is what we're going to talk about spec-driven development. I've gone over that a million times, so let's put it this way. A poorly designed API will cost you more in the long run. It's very, very important to understand that you're building a contract, and with contracts, there are no shortcuts. There's no quick fixes. It's like security. You either say, I'm going to take care of security up front, or you will pay for it down the road. There's no maybe. It's one or the other. So spec-driven development lets us do is it lets us define our code or define our API before we start writing actual code. So before we have to start creating the services and the models and the actions and the controllers and the views, we can actually know what the API looks like. We can see how it interacts. We can do something that we do with development every single day. We can use design patterns and reuse code, meaning our API will look consistent, remain consistent. We can mock the API and get user feedback. Again, we do this with applications. We used to do prototyping. Even with Agile, we do Agile user feedback and Agile user testing. Let's do it with our API. You can make necessary changes because you're only changing a couple lines here and there. You're not rewriting the application. And then you can start coding to the spec. And again, the big thing here is you don't deviate. Think of spec-driven development as a hybrid between Agile methodologies and, dare I say, the W word, waterfall. Now, the idea here is that we're going to continue with Agile and do Agile, but we're going to do Agile in 2 different stages. So when I say Agile, what I'm referring to is once you create the spec is the source of truth. We're not going to go back and change the spec without verifying the changes that we make. Another way to think of it is we do our design, and we start designing, we get a good spec, and then we say we're going to go into development. Well, once we get development, we're not going to go back. We're not turning around and saying I'm going to change this or change that, unless we run into an issue. And that's the whole goal here, by the way, is to not run into those issues. If we run into an issue, no problem. We go back to the design cycle, where we design the API, we mock it, and we get real user feedback. We get real feedback from developers around the world, from our potential customers or potential clients. And then we can say, this works, this meets their needs, Or, no, we have to continue designing, and then once we validate it, we can go back to the code. Now, why this is so important is, again, I'm going to pick on Facebook's API, which for the most part is pretty good. But on one area of their API, they have an OGraph inconsistency, where if you search for, I believe it's name, you have to search one way. If you search for location, you have to search a completely different way. If you search for name and location, it's still a third different way. So you have this huge inconsistency where developers, it's not listening to the documentation, struggle to figure out how does this work. If they had mocked that service out and let developers take a look at it, they could have said, hey guys, this doesn't make any sense, can we fix this? It'd be much more usable for their developers. Instead, it's in production, and once in production, you can't change it. It's too late. So the goal here is that by carefully testing the API through this agile design process, we're going to discover 99% of the issues. And by discovering these issues and by having this solid spec, we're going to let our developers develop fearlessly. How many people have ever developed an API as part of a team? One of the challenges with that, if you don't have the spec, is you're really making decisions on the fly. Where I'm talking to you going, hey, I designed this resource to look like this. Is this how your resource looks? Okay, is this your data structure the same? Well, how are you handling the errors? And so we start making these things up as we go. And if I'm working with one person, if it's just me, that's okay, except there's going to be some minor inconsistencies because we work on a project over time. And if it's two people, we can still work pretty collaboratively together. And there'll be some more inconsistencies, but it won't be horrible. Imagine if there's 5 people working on it. It just exponentially increases. Now, there's a problem with this. We say, this is great. We're going to design this thing. We're going to mock it out. The problem has been, that costs a lot of money. That takes a lot of time because we actually had to build the API to do this. The good news is there are tons of new technologies out there that allow us to do this very quickly and very easily. And we're going to show you some of those tonight. One such technology is called RAML. Now, imagine being able to design, prototype, document, and allow user interaction for your API, all with a spec that you can literally write in minutes. Now, I want to be very transparent. There are several different specs out there that you can use. There's RAML, which is the RESTful API modeling language. You may have heard of IODocs by Mastery. IODocs was one of the original specs that came out and it's used for documenting your API and creating interactive documentation. There's Swagger. Swagger is moving more towards being designed first, but same thing, documentation, server generation, and then API Blueprint, which is another good spec, but more focused on the documentation aspect. So what separates RAML from these guys? RAML's designed as a modeling language. The idea here is that you can model your API. Now, no matter where you're at with the API design, whether you've got a pre-existing API or you're building an API, you can still use this. It was designed to encompass the full life cycle, though, so that if you're starting from scratch, it helps you there, too. It was designed to really make us focus on the design, and focus on the design in a way that we tested it, it makes sense, and we do the same things we do as developers. Implement best practices, implement standards, reuse code, reuse patterns. And one thing that makes it very different is it's based on YAML. YAML is yet another markup language, or YAML ain't markup language, depending on which definition you go by. I think the latter is the newer one. But it's designed to be human readable, so that means as a programmer, you can design the API, you can do all this, but your API documentation team can then grab a hold of it and update the documentation aspect of it. And we can work in tandem, and there's no technology barrier. So what's RAML look like? If you look at RAML, this is a RAML file. So if I wanted to create a resource called playlists, how would I do that? It's literally \playlists. Or if I want to create a method called get in playlist, it's as simple as saying get. I want to create a 200 response. So again, somebody can look and go, this makes sense. I can incorporate examples. So if I want to return JSON, I can put an example in there so developers can see what it looked like. If I want to return XML, I can do that as well. But this is what makes RAML amazing. Not this, this. With RAML, you can define your API in just a few lines of YAML. You can see what your API looks like as you design it. You can quickly prototype your API with the click of a mouse and send it around the world for developers to try out and try as if it was a real API. You can quickly make tweaks and changes because, again, you're not changing code. You're changing that file I just showed you. You can easily document your API from that file. You can let developers try your API online from that file. You can let developers interact with your API and generate SDKs from that file. Even cooler, you can do parallel development from that file. We had a customer of ours, where they came to us and said, we have an issue. We are behind on the API. We promised our mobile team we'd have this API done, and we're going to miss that deadline. We're like, OK, no problem. When did you say you'd have it done? Tomorrow. OK. So you promised a whole API tomorrow. With RAML and the mock server, we were able to create a mock of the API, exactly how the API would work, that night, hand it to their mobile team. Their mobile team was able to develop the mobile application at the same time they built the API, because they were building from the same spec. What that meant is they could have saved 3 months' time and knocked out both at the same time. Also, you can use design patterns. Like, I keep saying this because this really makes RAML unique. And you can reuse code. You can set up the code or a template one place and reuse it time and time again. So again, with RAML, you can design your API, maintain your API, document your API, and provide interaction. And we're going to take a quick look at 4 different tools that do that. The first is the API designer. How many people here know RAML? OK, you're all going to learn tonight. That's part of the whole hour presentation. No, I'm just kidding. With the API designer, it's going to walk you through how to use RAML, so you don't have to know how to start writing it to start using it. The API console provides interactive documentation that lets developers try out your API in real time. There's RAML to HTML. There's RAML to HTML for PHP. This is my shameless scripts. We will show it off, but there are plenty of scripts for Java as well. And the API notebook, which really changes the way developers interact with your API. Here's my disclaimer. All these tools are open source. So I'm going to show you MuleSoft's hosted version. You can download them from raml.org/projects. You don't have to use the MuleSoft tools. I'm just being lazy in that regard. So this is my favorite part because this is the live demo, which means that something will go wrong. And so I just want to thank you all for your patience ahead of time. So we want to create an API here. We're going to call this East Bay Java API. And we're going to say, let's add a version here. So if you look down here, it tells me what actions I can do. Perfect. So I need your help building this API. What's a resource we would want for our API? Pizza. A man after my own heart. So if I want to add a pizza API, again, it's just \pizza. And you'll notice immediately to the right, I have a resource called pizza. Well, what methods should I have in this pizza resource? Let's say post. I want to order pizza. So I'm going to add a post method. And you notice as soon as I do that, there's a post. But more important than posting pizza, we want to get pizza, right? Again, just by adding it, it's there. Maybe I want to add a description. And you notice, again, it's going to autofill this for me. So you don't have to fully understand what RAML does. It is the source of truth and life. And I can do the same thing for get. Again, it shows me exactly what the options are. If I want to add query parameters, we can say query parameter toppings. And then let's do a response. So I can do body, I can do headers. Let's do XML just to go old school. I can put in a schema, I can put in an example. Now, just by doing that, if I go into this get here and click on that, you'll notice I have query parameters. I have a query parameter of toppings, which is a string. I can see what my example body would look like. But let's go a little bit more in depth, because we build this API, we want to get real user feedback. So I can click the mocking service here. And the mocking service is going to create a base URI. And you can change this for your real API, but now I have an actual mock of this API. So let's do version 1, because I'm too lazy to type in v/1. I can now click on get. I can click try it, toppings. And now I can see exactly what I'd get back in real time from this API. Can everybody see that okay? That's cool and all, but this is this little admin tool. Wouldn't it be nice if I could share that with other developers? Maybe.
So I have a question.
Yes.
So if you're going to have a client wrapper around this,
Mhm.
you would need some types for like query parameters and stuff like that.
Mhm.
Is there a way to specify types?
Yep.
in that?
Yep, so anything you can do with the API, you can do query parameters, you can do UI parameters, you can do types. You can say this is what I need coming in, this is what I require from it. You can require post data. You can say this field's required, this one's not. So really anything you can do.
YAML.
Yep, it's all based in YAML. Yep. Same thing, I can go to the resource.
Do you have an example to show of that? Maybe?
Of which one exactly?
Like, like how you specify types in the YAML.
So which type do you want it? Sorry.
Well, yeah, just something as a string or an integer or something.
Okay, so for that one I would just say type string. And then I could say, and again, it's going to show up right here to say, okay, I can put in a description for that. I can put in a display name as for that. And then I can also put an example, which would be shown to them in the documentation.
And you can have lists of things as well? Or?
Yep, so it'd just be like an enum. Yep, so you can do lists. Let's see. Let me save this. Oh, I don't have the version in the URL, that's why. So if I want to add the version in the URL, I just put the version which is reserved. Make sure this is saved. And then just because it doesn't like me, it's not going to. So believe it or not, that actually does work. I'm not sure why it's not working in this case. I'm probably doing something stupid, which will be a pepcac error. But with that, I can then send this, and so they could be using tools such as their browser. They could use the API console, the API notebook. They could use one of the many plugins such as Postman to make these calls and really try out your API. And again, anything you can do with your API, describe your API, you can describe with RAML. So if I want to add additional resources, if I want to add a specific ID, for example, so we want to do, I can create URI parameters. The other nice thing about RAML is I can nest things. So instead of having to say, okay, here's a resource, here's a resource, here's a resource, I can nest the child resources in the parent resource, so it's all nice and categorized and organized for me to use it. You could also do multiple content types. Maybe I want to return JSON. Well, I cannot type today. You can do multiple content statuses. So we'll jump back and maybe we have a 400 error. And again, as I do this, it's all being shown to me in real time. I can create the mock, I can show developers, but more importantly, I can see what's happening as I design it and what it looks like. And as I add the resources, it continues to grow. With that, you can then take that spec, and this is an actual live API, and use something called the API console to actually share this on your own site. So once I built this API, and I have this design, and now I want to publicize it, rather than have to create all this documentation myself, I can say, hey, here's the source of truth, here's a spec. It pulls in this URL and automatically generates, just like we saw to the right of the API designer, a spec that your users can jump into and say, okay, I want to know what locations does. Well, here are the parameters, here's how it works. And then likewise, they can say, I want to try this. And here's my disclaimer. Yeah, last time I saw it, AB had actually taken this API offline. So forgive me for that. But again, it goes to the API. You can get the actual responses in real time.
So how does your YAML language compare with Swagger's language?
So with
Basically the same thing, right? I mean, conceptually they're similar, right?
they're very similar. So the structure is slightly different. The verbosity is slightly different. One of the challenges with Swagger, and I'm a fan of Swagger actually, I bug around all the time on it. Swagger was originally designed for the documentation standpoint, and they're moving towards design first. But when they designed it, was here's your documentation, here's your SDK generation, here's your server generation. Starting from a design state wasn't what they'd originally planned for, and we saw a move towards that in Swagger too. With that move, though, we saw some challenges. One of the challenges with Swagger is Swagger is still JSON first. What that means is that you have, really, if you want to use any of the old tooling with Swagger, you have to maintain two different specs. You have to have the JSON spec for the old tooling and a YAML spec for newer tooling, which creates kind of a challenge with that.
Also, their standard is YAML now?
Yeah, so they're in this gray area where it's actually both. It's JSON YAML. They now allow you to design in YAML, but eventually that has to be compiled back down to JSON, especially if you want to use any of the old tooling. So they're trying to get there, and they're doing a lot of great work. And Apogee just released their API Studio, they call it, which you'll notice there are a lot of similarities. They're trying to go the same route, which is good. Because when we talk about these different things, eventually we all want a single source of truth. We don't want the debate, do I use API Blueprint or RAML or Swagger? But it just, with every spec, there are strengths and weaknesses. In fact, to do some shameless plugs, since you asked about that, if you go to a site called Mike Stowe, and you click on the spec comparison tool, you can see the different specs compared side by side. And again, I'll be very transparent because you want to use a tool that meets your needs. Myself, I'm a fan of RAML. One of the reasons I'm a huge fan of RAML, also in the comparison, RAML lets you do code reuse and design patterns. That's something that Swagger doesn't support in the same capacity yet. Down the road, hopefully they will.
What do you mean by that? Can you go into more detail?
Yeah, yep, so I'm going to jump in that in a couple seconds with an example. But essentially, you can create a template. So rather than have to rewrite the resource code 15 times, you pull in that template and just say, this is the example. So it reduces the amount of code that you have to repeat over and over again. Think of it as having a function in your class, or a method in your class. They're able to use that method again and again and again, setting the day that you need to change. So here's the transparent strengths and weaknesses. I mean, for me personally, the spec, again, with RAML, it's a little bit easier to use, in my opinion, versus the YAML spec of Swagger. People are going to look at that and say, no, this one's easier, this one's easier. That's for you to decide. But again, the ease of spec maintenance with YAML or RAML, you have one spec, which is YAML. With Swagger, just be aware that you'll have to use two. That may not be a bad thing, that may not be a big thing. They have converter, but just be aware of it. With application and tooling out there, Swagger has more language support. RAML is catching up. RAML now supports all the major languages, but Swagger has things for like Go, for example. Again, Swagger is taking huge steps forward with their API designer, but they don't have the code reuse. Thanks to Apogee's new APIs too, they do have a similar mocking service that you can use, which was a great advantage and big plus. Generating your API, Swagger is going to have more tools for generating your API. So if you're saying I want to support a framework, RAML's catching up in that regard. But right now, Swagger has more support for tools like Compatibility. If you're using like JaxRS or Jersey, that supports both Swagger and RAML. Documentation, again, is identical pretty much. Tooling is going to be stronger on the RAML side for interaction. SDK generation, a little bit stronger on the Swagger side. But with services like API Mag.io, you can generate SDKs for really any language that you want. And then you're going to see there's strengths and weaknesses in the community. So again, it depends on what you're looking for in particular. Myself, again, my recommendation is use a tool that meets your needs. I'm a fan of RAML. If Ron was here, he'd be wearing a Swagger t-shirt, saying no, use Swagger. One of the reasons I also like promoting RAML is some of the tooling, which I'll show in a second. But again, if you want to generate full documentation for your API, whether it be the RAML file or the Swagger file, having one source of truth, we can generate the entire documentation for Twitter, for example. And I can actually dig into this and have a dynamic page where it's like, here's your description for that. Here are your available actions. I can click on that, click on Git. Here are your query parameters. Here's your responses. All this documentation is created for me automatically in a template-friendly system. I mean, I can make it look exactly how I want on a website. I didn't have to write a single line of that other than in the RAML file one time. I have to create these pages. I don't have to maintain this. I update the RAML file. It's good to go.
So what
Yes.
do you say about Jersey? So you can create Jersey like server-side skeletons for this?
Yep. So this one's actually a PHP script right here for the documentation, but you can generate your application or API in Jersey and then in JavaScript and a couple other applications, and both Swagger and RAML have those capabilities. But one of my favorite tools, though, is the API Notebook. And the API Notebook is one of those that when I first looked at very honestly, I was like, this is kind of silly, what's this do? What the API Notebook is it's an explorer for your API. We say we want to provide code examples to developers to help them write code. With the API Notebook, we're providing API usage examples. So in this case, I have the Twitter API, and I want to find out who my last follower on Twitter is. This is actually walking me through step by step what API calls I'd have to make and how I'd find that information. So let's just click on this guy right here, because one of the challenges with Twitter is it uses OAuth 1. That's never fun to work with. But the API Notebook, just by having 3 lines in the RAML file, which basically says here's the OAuth 1 token, here are the different things you need to know, automatically pulls that in. So I can click Authenticate here. And if I put in the right username and password, you'll see that it has made that call. And you can actually see my access token and my OAuth secret. Please don't use those. But now what I can do is I can actually explore the entire Twitter API from that RAML file. So anything I can do with the Twitter API, I can say I want to do friends dot, and it'll actually walk me through how to do that. Where this becomes extremely useful is, again, I want to get my followers. I can click, let's click play all the way down here. So it returns the object. So I can actually say, what did this do? What did it return? Or returned an array. Here are the IDs in the array, so I can see exactly what data I'm getting back, all exploring the API without having to do any coding or anything on my part. And I can find out the most recent follower ID, and eventually the most recent follower screen name, which in this case is defrag. So not only do they get to explore your API, they get to see exactly what responses they get and see how it works, which helps them develop on your API. But the flip side of this is support. One of the challenges with support is I try your API, something doesn't work, I write to you and say, hey, I did some stuff with code, here's a portion of my code, it doesn't work. From a support standpoint, you're like, that's great. Is it your code? Is it the API? I have no clue what's going on. There's all the backend code, proprietary code that you're not sharing with me. I can't tell you what's wrong. And so these issues become week-long searches where we try to figure out what happens. With this, I can create my own notebook. It's all based in the Markdown format, which means that if I run into an error with this, I can recreate the error I had, say, this is what I tried calling with your API, this is what didn't work. None of my proprietary code, no guessing on your part. I send this to you, say, oh, this is what you did wrong when making the call, or, oh, this is a bug and we can get fixed. So you're getting reproducible support tickets right off the bat. And that's one of the reasons I really like the API Notebook. Right now, there is no alternative for the API Notebook for Swagger API Blueprint. Seriously, I hope that there will eventually be one, but right now, that's only available for RAML.
So the notebook allows you to have a sequence of steps that reproduces?
Mm-hmm. Yep. So you can say these are the sequence of steps to make this call and get this information. Or as a developer, I can send back a sequence of calls in Markdown and say, hey, I tried making this call and it didn't work. The other nice thing about this is, let's say I want to get really fancy and I want to add another API. Any API that's described in RAML, I can add. So maybe I need the Twitter API to work with the GitHub API. I can pull that in. Now I can make calls to both these APIs, and before I invest in your API, say, does this work? Does this meet my needs? Can I use these both? So it really allows developers to explore your API in a format that they could not have previously.
So I guess I'm not quite sure how this would be used. So there has to be some backend code that actually implements these calls, right?
So,
In order to reproduce it. So how does that work?
so the way it works is this is actually based on Node.js. So you either go to apinotebook.com and you can put the examples there and save the examples, or you download the open source API Notebook, host it on your site. But for the calls here, this is the code that they need to know. This is the only thing they have to touch. There's no coding by me. There's no coding by anybody else. I simply say, like in this case, when I wanted to create the GitHub API client, by clicking that button, it created that client for me. I don't have to know any code. I don't have to go in and dig in any code. I can actually do all this just using basic JavaScript from the front end. So it takes out the complexities of having to write code. It also takes away the complexities from people trying your API. Gareth Jones, who runs the OneNote API, he made the comment. He goes, "This whole idea is great, but developers don't want to write a bunch of code they have to throw away." Exactly. This allows them to test your API and give you feedback without having to write a single line of code. In fact, if I jump in the source, because you're saying, well, what's this look like from the code side? I can do it from there.
I still don't understand how how the back end of this thing works. That's
Mhm.
confusing to me. I don't know. So what I'm understanding is that you create this thing. This is like a script,
Mhm.
and you run the script, and it actually interacts with some server
Mhm.
to do some things.
Yep.
Right? Where's the code for the server coming from
So
to actually implement the API?
so that'd be from the RAML file. So if we go back to the RAML file there, we'll have the base URI. So what it does is it grabs the URI and says, this is the API I'm talking to. And then all the rest is handled by the browser in JavaScript. So they don't have to point server code because they get the RAML file. The RAML file tells them what server they're talking to and what the server requirements are. So they're able to grab.
There has to be some server back there that we're talking to.
Right. So
Well, is it like Twitter?
It's a public service.
Understood.
So
Yep.
where did that narrative text come from? Like when you go back to the notebook.
mhm.
I mean, like Twitter has a thorough API. You know, where's that wording? Is that just comments in the RAML file or what?
So like the read about the Twitter REST API or?
Yeah.
Oh, yeah, so we type that. So if I jump here, you'll see this is all markdown. So I can add that in. I could say, and it'll update for that. So it's just markdown.
That even opens up. So how does this markdown relate to the RAML? Like, what's the process for creating?
So if I want to create a new API notebook, there's two routes you can do. You can do the modification. I can actually edit it right here.
Yeah.
So there's the visual editor, and then I can jump into Markdown, at the Markdown directly. And then if you host it yourself, you just connect it to your GitHub account and store it in the GitHub. If you host it with API Notebook, they store it on their GitHub for you. But essentially, again, you could decide, do I want to do, think of the WYSIWYG editors for blogs. Do I want to do it the old-fashioned way and write the Markdown, in which case you can see it's all very basic Markdown, or do I want to go in and do I want to insert a code cell?
Yeah.
Yep. So you can actually use it to auto set up those things for you. Does that make sense?
So you have to get the RAML file somewhere.
Yes. Yep. So this is dependent on the RAML file.
So how do you load it in?
So the way you do that is if you click on Insert API Client, you just pull it in that way. And I was talking about like the.
Repository of all these RAML files that you're looking for?
Yeah. So this one's pulled from the MuleSoft repository, but you can actually import your own RAML files. And again, this is open source. You can download it yourself. You can pull your own in. You can actually just create your own. Oops. Like if I jump back really quick and I just change this URL, for example. That's what's pulling in. So I'm telling it, this is where the RAML file is. Grab that RAML file. And we were talking about like the OAuth aspect, by the way. Here's the information for OAuth. So all that OAuth complexity, I don't have to worry about. I just simply declare this is what links it should use. And the API Notebook handles all that for me. And I'm more than happy to go through and show the API Notebook and give more examples and stuff. I don't want to take all the time on that. But essentially, what these tools are, they're new ways that you can design your API in real time and visually, but new ways you can share your API as well without having to do all the rework yourself and having to write complex documentation. Yes?
You have a bunch of public APIs for which you have the RAML files.
Yes.
Are there well-known public APIs for which RAML cannot model? RAML can't model anything?
So there are known APIs that RAML can't model. RAML is designed to be a RESTful API model language. So it's not going to model a SOAP API, for example. That'd be something you run into, and you need the WSDL. Any API that adheres to the most basic aspects of REST, so it doesn't have to be a REST API by definition of the constraints or definition of right fielding, but if it's an HTTP API that follows, uses a GET method or a POST method or the other methods, it can be described with RAML. So the content types are unlimited content types. So if you return back objects, for example, you typically say the content type it returns back is application / the object type. So it really supports and has a lot of flexibility from that standpoint. But it is limited to HTTP APIs and it is limited to HTTP APIs that use get and post and patch and put and delete. Yes, sir.
Yeah, when you mentioned, I guess, generating SDKs or API SDKs,
Mm-hmm.
is that for the sort of language-specific integration points for the API?
Yeah, so there's a service called, so it'd be for if I'm a developer, I want to implement your API, and I don't want to have to create my own curl client, for example, in PHP, or my own service in Java. One of the services out there is APIMag.io. I'm just going to pick on them really quick. APIMag.io actually lets you generate SDKs for Windows so they can create Windows native apps or Windows mobile apps, Apple apps, iOS apps with Objective-C, Android apps, which I believe uses Groovy or Grails. You can create the standard Java, PHP, Python, Angular, Ruby, JavaScript, and then I have no clue what this guy is. I should know what that guy is, but I don't know. Oh, Go. So they just added Go to their list as well. So all those you can easily generate from the RAML file. And so it's just literally you say, here's my RAML file, generate these SDKs. Now here's my disclaimer. Anytime you do an auto-generate SDK, you should go in and verify it yourself and make sure that's good. I can't speak to the quality every single time. What I can say is we've used our SDKs for other services without any issues.
So this site is tied into the RAML file, like you have to give it a RAML file to it?
Yeah, yep. So if you give them a RAML file, so they actually support several different specs. If you give them a RAML file, they'll generate those SDKs for you.
Is there like some kind of thing, like a command line thing, you can take a RAML file and generate it?
Yeah, so you'd log into their web console.
Oh, the web console.
Yep, the web console, and you just say, here's my RAML file, and then it would generate that. Yep. I think they have like a command line kit, but I haven't played with it. There are also open source tools. If you go to raml.org/projects, you're going to find a ton more projects. You can generate some SDKs for RAML from the command line. You can there's a tool called Abeo, which lets you do testing for your API. So once you build the API, you can actually use that same RAML file to do all your tests and say, hey, does this resource work? Am I getting what I expect? Again, to be very transparent, you're going to add more tests than just what it generates from the RAML file, because you want to say, well, what if I do this? Do I get this data exactly back? But just about any type of project you can think of, it's an open source community. There's something out there for it. In fact, just for fun, my goal, by the way, is just to keep flipping back and forth just to see how long I keep you guys here. But so there's the API designer I was talking about, the API console, API notebook. There's tools for .NET. There's a SOAP UI plugin. You can actually use MuleSoft's Endpoint Studio, take a RAML file and generate the full API from the RAML file, and then use it to connect with databases, things like that. JAX-RS, tools for editing with Sublime, documentation. There's an Atom package, generate with Osprey. I mean, the list just keeps going on. And we're still adding more and more to it. We actually have a whole backlog of projects we haven't added just because it wasn't a good searchable system. So that's coming, but I mean, there's a lot of different projects out there that are all open source that you can use. Yes?
Anything that generates database schema?
So not that generates database schema. It shouldn't be that hard to grab one of the parsers and then write a script that does that. That's how you know I'm a developer way. It shouldn't be that hard. But there's nothing that I know of, at least that's in that list. There may be an open source project somewhere that's not in the list that does that, but nothing that I know of. The other big thing with RAML, and again, one of the reasons I really promote RAML versus other tooling, and I feel like a broken record here, but again, is the design package and the code reuse. And what that means is we have two different solutions or two different parts of RAML you can use. The first is called traits, and traits operates just as any trait would in an application. It's designed specifically for methods. So if your method is filterable and you say, hey, look, all my filters should operate in a similar manner, or it's searchable and you say, oh, I want all my searches to operate in a similar manner, which in 99% of the cases you want. You want me to be able to search one resource the same way as another. Obviously different data, different requirements, but the overall structure of the search should be the same. Or if it's pageable, the pagination should be similarly structured across your different resources, so I don't have to relearn it every time I use a resource. Resource types, on the other hand, are patterns for the resources themselves. So maybe for a resource, you typically have like an item resource. And for an item, you have a get to get the item information, you have a patch, and a put, and a delete. You can say these are the items that are typical. More importantly, you can list them as optional, so they'll only be added if you say add this item in the resource. And then for a collection, you typically have get and post. You typically don't want to allow people to edit an entire collection or delete an entire collection. So it allows you to set up these templates right off the bat. So for a trait, for example, we could say, I want anything with this trait to be searchable. And that means it has a query parameter. And the query parameter, there should be a description for it. And the description should have excuse me, a field, a value, and an operator. And this is what the example should look like. Now, instead of having to repeat this every single time, every single method that I want this trait applied to, I simply say, here's my songs resource. Here's my method get. Get is searchable. The description, right here, with valid field, song title, and then example, song title, get, L, and like. So rather than have, again, repeat all this, I'm able to pull this in one time and keep it all very similarly structured, which means all my documentation will look the same and the way it interacts looks the same. On the resource types, in this case, we say we have a collection. For the collection, the description I want to be get a list of resource path name, and each collection has a response of 200 with a body of application JSON and example. Now, in this case, it's like, okay, why would I want to do that? Well, if you think about it, I have a 200, maybe I have a 400, a 401, a 404, a 500. You start repeating a lot of things again and again and again because it's very verbose. This way you can avoid repeating that. Rather than having to have your error message repeated again and again and again, you can store it in one place. And in this case, I'm simply saying, hey, this is songs. The songs resource is of type collection, which pulls in this right here. And hey, here's my example collection. And so all this is pulled in for me. I don't have to repeat that. And it automatically pulls this in and puts it in the example collection. So it's a way of, again, creating templates. So again, everything looks the same, works the same. And as a developer now, I don't have to figure out, well, how do I make it exactly like the other resources? It just is. Does that make sense on the design patterns and kind of code reuse aspect of RAML? Awesome. So one thing I really want to point out is that with spec-driven development, it's not just one and done. One of the problems we have with waterfall methodology, by the way, is we say, look, we're gonna put together this huge document. You're gonna design from this document. There's no flexibility to it, and then we're gonna throw it away, because that's what we do. That's not what spec-driven development is designed to be. Spec-driven development is designed to be, we're gonna create the spec. We can change the spec if we find problems, but we're gonna test it and make sure it makes sense, and that any change we make doesn't have a long-term consequence. And then we're gonna continue using this spec, because this spec can be used as a source of truth for our documentation, our interaction, our SDKs. And when we update our API, rather than just saying I'm going to change code and put in production, we're going to change the spec, test the spec, validate it, and then change the code and put in production. And the idea there, again, is very simple. We don't want to start changing things on the house without thinking it through. We don't want to box ourselves off so we can't continue to grow and extend the API. It's also important to incorporate best practices. And by the way, this is the double whammy, so I apologize, because you actually got two presentations combined into one. When you build your API, especially a RESTful API, you want to use nouns. You want to utilize CRUD or HTTP methods. We're talking about hypermedia. You want to use the accept and content type header, return header codes, and return descriptive error messages. And these are my big pet peeves, which is why they're here. First of all, use nouns with your API. What that means is, if you want to have somebody use users, to modify users, use users. And in nearly every case, you want that to be plural. Unless it can absolutely only be singular, make the name plural. What you should avoid, though, is things like create user, get user, delete user. And the reason for that is once you start doing that, you're going more towards an RPC-style API. That also ties you into that resource name and ties you into that action. It also opens you up to confusion. For example, I went to one API where it was delete user and remove user. Well, what's the difference? So this way you can use methods to be explicit with it, but use nouns. Utilize CRUD, and CRUD stands for create, read, update, and delete. Generally, what you want to do with CRUD is you want to use post for create. Now this gets confusing because if you read the RFC for the HTTP methods, there are different weird things you can do with these different methods. In general, if you're going to create something, you want to do a post. If you need to do a complex search or something, you can also use a post, but try not to complicate it. If you're getting a file, if you want to read the file, you want to use a get. To update a file, you want to use put and patch. And it's important to understand the differences between the two. Put is designed as a complete override. So if we have first name Mike, last name Stowe, city Oakland, and I do a put on that, and I want to change the city to Union City, and that's all I send is the city property, what we'll have back is first name blank, last name blank, city, Union City. It overwrites everything. A patch, on the other hand, says only update the information I give you. So making that same call to patch, it'd still be Mike, Stowe, Union City. So understand the difference between the two. If you use them, make sure you're explaining to your developers what a patch does or what a put does. This is something a lot of developers still struggle with. Delete, on the other hand, does just that, delete. The big thing I'd throw out there is you don't want to offer updates or deletes on collections. Just because chances are if I go to /users, I don't mean to delete every single user. Hypermedia. Again, we turn hypermedia into something that's very complex. And there's something called HADIAS, which is hypermedia as the engine of application state. What that essentially means is that REST is stateless. So because it's stateless, I don't know what's going on as a client. If I get a user, I don't know that user's state. So what HADIAS says is I'm providing the information for you so you don't have to understand my application rules. So let's say you get back a user, and it's a standard user, but they've been suspended for spamming. You might get back links that say, for this user, you can delete the user, or you can unsuspend the user. Maybe you have another user that's a super admin. You'd get back links saying you can message the user, you can edit the user, but you can't delete the user. So what we're doing is we're conveying what state the object is in, but more importantly, what actions they can do. If you think of hypermedia, think of a choose your own adventure book. You flip to the page and say, okay, this is great. This is where I'm at. Here are my options. This is what I want to do. And you click that link and you go to the next place. Yes, sir.
So is the hypermedia also, in the real REST thing,
Mm-hmm.
is the hypermedia also supposed to follow the REST conventions of, slash some collection, slash, ID, blah, blah?
Yeah.
Or because what you were saying was each one of those was an action.
So with that, there are different specs out there, and so there's different routes you can take. Traditionally, the specs have been resource-based, meaning that here's a resource for the user ID, and then you'd have to say, okay, what are the options for that user ID? Do I want to edit? Do I want to delete, etc. PayPal actually did something very interesting with their interpretation of, I believe, the JSON API spec, where they actually included it based on the actions. And there's specs like CPHL and Siren, which also are action-based. So it's
Recommended that if you have a REST-based top-level interface, that your hypermedia is also REST-based?
well, so it's still REST-based, because with REST, the REST does not declare that the hypermedia has to be ambiguous. And so this is something that's still being figured out. And actually, Roy Fielding doesn't really jump deeply into the HADIAS aspect. So there's nothing in his dissertation that says you cannot say this is a link and this is the method you should use to edit this. It's not described one way or the other. And this is one of the challenges we have with hypermedia, to be very honest, is if you look at the state of hypermedia, we're still learning a lot about it and still exploring. Like I said, people are still adjusting things. You have a lot of specs out there, such as HAL, which is the Hypertext Application Language, which is a great spec. I'll show you in a second. JSON-LD, which is a linking definition. JSON API, collection plus JSON, Siren, which is new. But the reason we have all these different specs is nobody has the right answer exactly, and we're still trying to figure out what it is. Myself, the big reason for hypermedia is to be both human readable, but more importantly, machine readable. So let machines understand what their actions are and to explore your API. I'm not a fan of having an ambiguous link and making an options call to say, okay, what are the options I can do against this user? I actually prefer having the actions listed with that. Does that mean it's right? Absolutely not. It really depends on what works best for your developers, for your users, and what ultimately is going to save you calls to your API, and be descriptive without turning into something like Waddle, because we don't. That's what we're not trying to do. We're not trying to create like a WSDL for APIs. We're trying to create a path that helps people understand what their actions are and what the state of that item is. So one such linking system, again, HAL, what it looks like is you're simply saying, here are the links. And again, to your point, do you have to say edit explicitly, or could this just be, in this case, it'd be self? So if you have a list of users, you could have links, and it'd be self. This is the user ID. This is where I go to get the information, to delete the user, to edit the user. Or if I want to message a user, here's the options I have for message the user as well. So the hypermedia really just describes, here are the actions you can take with this item or with this object. But you're right, there's no exact standard on how it should interact, which is why if you look at JSON API, it's a little bit different from HAL, which is very different from JSON LD.
So is there also a standard for representing the structure of the body that comes back as a YAML thing?
There really isn't. So the rule with REST is that it's a representation of the item. Whether that be JSON or YAML or XML, there's no strict, it can be whatever meets your needs. One thing that they tried to do with REST was make REST dynamic and pliable.
Well, I'm not talking about the language part, just the structure. I mean, you could, if you're using YAML, then you could define the structure of the response as a YAML specification.
Yes.
Or JSON specification, whatever you like, but in your case, it would be YAML. But there's no standard as such like that, right?
There really isn't. I mean, you can use so you don't have to, using RAML by the way, you don't have to return the response for your API as YAML. RAML supports content types such as XML and JSON. So you'd simply say that. If you're using XML, you'd probably use a schema. If you're using JSON, you may or may not use a JSON schema. If you're using YAML, very honestly, I don't know if there's a schema set up for YAML yet. I'm not sure on that one. So it depends on what type of content type you're using, and then whether or not you use a structure for that. But both RAML, again, is designed to allow you to have a type of representation. And with REST, it doesn't say this is what it has to be. There's no standard that says it has to be YAML or it has to be JSON or it just has to be representation, which is really why the interface stays the same. Because you're not necessarily getting back to the exact object, because if you're getting back to the exact object, if you change your architecture, then that would change. So that's why the representation and the interface. Which actually brings us to the next point, using except headers and content type. Even if you only have plans to return back one content type, even if you want to say, look, all of our responses are going to be JSON, build this in. Take a content type, take an except header, and return based on that. Traditionally, I mean, you have to weigh this. And the reason I say use both is because if I'm trying to get a CSV, I'm going to have to send a JSON post and ask for a CSV back. But usually it's going to be whatever the content type is what they're trying to get back. So if I send a JSON request, I'm trying to get JSON back. But just understand, again, it may vary based on your use case. The reason this is so important, though, is because we did this once with SOAP. We said, we're going to use XML. This is the greatest thing. And then people started demanding JSON, and we're like, crap. We don't support JSON. There's no way for SOAP to support JSON. We can do the same thing if we're not careful with REST. If we say, we're going to support JSON, and we build it so it only supports JSON, and then let's just say YAML, for example, catches on fire and becomes, YAML, by the way, is great for API description. It's not really great for returning representations of resources, just as a heads up. But let's say it catches on fire, so we give that back. If we've built it without checking the content type, we have no way to change that in our API, and we're stuck with JSON. By building it in, and by having a view model and a view layer in there that handles this for us in our application, as times change, it's as simple as adding the view for that and saying, oh, okay, serialize this as YAML, return the YAML. Serialize this as JSON, return as JSON. And now we can support multiple languages and our developers' needs and our customers' needs. You get a large enterprise that says, hey, you have a great API, but we can only work with XML. No problem. We have the ability to add that functionality without changing our architecture and without changing the objects and resources. So again, you want that. For that, keep in mind that there are strengths and weaknesses of different response types. One reason why we push for JSON is it's less verbose. It takes a lot less data to send JSON than XML. Also, there's wider language support. So it's easier to deserialize and serialize JSON across the board than it is to do that with XML. It becomes far more complicated. Use response codes. This gets missed. People always give like a 200 or a 400. The response codes tell developers what's going on. And there's some common response codes you should use. 200, that means the request was OK or it was updated. 201, if they send a post and they create an object, you should send a 201 saying that object's created. If you're like super RFC guru and you're like, look, I'm going to do a put, which actually creates something, you have to use a 201. If they send an update, a patch, and it's not modified, let them know. Send a 304 saying nothing changed. 400 bad request, 401 not authorized, 403 forbidden. Method not allowed. Maybe I try to do a delete, and I don't have permissions to do that, or that method's not allowed. Method's not allowed. Unsupported media type, I request XML, you only support JSON. Or my favorite one, something went wrong, we really have no idea what, 500. And if you want to get really, really fancy, there's a couple other ones you can use. You can use 418, which is I'm a teapot. That's an official RFC code. However, you should only use that one if the server is actually a teapot. That's one of the requirements.
I used that in a talk, and there was one person who got that joke.
That is awesome. I love it. The second one is not a real status code. This was invented by Twitter. It's 420 enhance your calm. I'm going to be honest, I really don't get that one. There's a different status code for too many requests that you probably want to use, but if you want to have fun, you can use that one as well. This is actually my biggest pet peeve. Use descriptive error messages. Tell developers exactly what went wrong, because I've made API requests and got back something went wrong. Duh. Did not know that from the error. I actually got back one that says, we are preparing the rocket ship. I was tempted, I think it was from someplace in Texas, to get in my car and drive to Texas to see this rocket ship because I was that aggravated. Now, this is just a quick example of what a descriptive error message should entail. Please keep in mind, we have standards for this. There's error.vnd. JSON API has a built-in error spec for it. There's Google Errors, which is fantastic. So you don't have to reinvent the wheel. This stuff is already out there. But you should tell them, give them a code, what the error is. That code can be specific to, this is a 400, or specific to a support code that when they call in, your support team's like, oh, give me the code, I can look it up. You should give them a message. The message is just a quick, something went wrong, but tell them what went wrong. You're missing a user ID. Give them a description. Let them know how to fix it. Okay, missing user ID. A user ID is required to edit the user. This is why this didn't work. And then give them a link to documentation. The idea of an error message is not just to tell the developer things didn't work, but help the developer use your API and fix your API. So give them the link and say, this is where you can learn more. This is how you can fix it. Keep in mind that this is one of the biggest issues with APIs. If I can't use your API, I'm going to find an API I can use. That'll probably be your competitors. Also, documentation is one of the easiest ways to kill an API. And this is why we promote spec-driven development, because it keeps everything up to date, up to sync. Consulted with a company, I'm not going to say who, and we got down, they're talking, they said, yeah, no, our API is, the documentation is just, it's so old. I'm like, okay, we can work on it. They're like, yeah, no, we've already planned to build a new API. Their solution to out-of-date documentation was to build a brand new API. And it sounds ludicrous, but people say, well, this doesn't work. And it gets to the business level of this doesn't work. They're not saying the documentation's out of date. They're saying the API doesn't work. Again, as a developer, if I can't understand how to use your API, if I can't figure it out, I don't care how greatly written it is, how perfect the code is, I'm going to find an API I can use, which means it's going to be your competitor. Enable caching. Again, tell your developers. Send back the result and say, can this be cached? Can you save this data? How long can you save this data? One of the biggest issues we have with APIs is the calls being made. I mean, people just hit these APIs nonstop. This saves me from having to make a whole bunch of calls to your API, which means my application is faster for my users, but it saves you load, which means your API is actually able to support more users, more people calling against it, and saves you time and money. So this is an asterisk one because I got myself in trouble with the guys at OAuth 1. OAuth 1 and OAuth 2 are different. You should understand the differences. One uses certificates, one uses SSL. In general, OAuth 2 is easier to implement for developers. And so I would tend to push people towards the OAuth 2 route. It also supports scopes, which means you can post this but not do this. So it lets them determine that. Now you can add scopes to OAuth 1. Twitter uses OAuth 1, and they have added scopes. You can say they're allowed to read your tweets but not post tweets. So you can certainly add it, it's just not natively built in. But what it comes down to is what are your security needs. OAuth 1 is more secure overall than OAuth 2. OAuth 2 again relies on hey, SSL, which that's going to depend on developers. Not every developer is going to use SSL. So unless you force them to use SSL, they're not necessarily going to use it or know better. OAuth 1, signed certificates. A lot harder to implement, a lot more secure. This is my ad for MuleSoft, which is an API management company. This really is an ad. Use an API manager. I don't care if you use MuleSoft. I don't care if you use one of our competitors, such as Layer 7, 3Scale, Mastery. I mean, I don't care. You can build your own if you want, but I'm going to throw a couple disclaimers. First of all is you want your API manager to act as a proxy. You want it in its own space. You do not want on the same server as your architecture. Because if you get a DDoS attack that takes down the API, you're taking down your entire system. So you want this to act as a layer to protect it. Secondly, there's a lot that goes into building an API manager. There's a lot on the security front. Unless you have the security expertise to build an API manager, don't do it. Same thing with OAuth. Unless you have the security expertise to build an OAuth solution, don't do it. For the OAuth side, OAuth.io has open sourced their entire OAuth solution. You can pull that in and use it and build OAuth 1 or OAuth 2. There are services such as OAuth.io again or Stormpath that provide OAuth management for you. It's just there's a lot of security concerns that come with this stuff. Same thing with the API manager. Even if you're using a free service, 3Scale offers a free trial or a free for so many calls and you have to upgrade after you hit a certain branch. Even if you're using something like that, just have something to protect your API, especially if it's going to be public, because even if developers aren't trying to be malicious, all it takes is one infinite loop to wreak some havoc. So just something to keep in mind. And remember, and this is really the whole point of this talk, and I apologize, I've just rambled on and on and on and on. Building an API is actually really easy. I mean, think about it, you're just writing code. There are frameworks out there that do it. There's Jersey. There's frameworks for every single language. Building an API is very easy. Designing an API that's going to be flexible, that's going to be extendable, that's going to be secure, that's going to be long-lived, that's really hard. And the reason it's so hard is because it only takes one little thing, one tiny little thing, some stupid little thing on one obscure resource that boxes us in, and we have to create a new API, we have to version. All it takes is one bug, one mistake, one design flaw to hit production, and you're on a downward spiral. And that's why we push things like design spec-driven development, and why we push things like RAML or using an alternative spec, and why we push these best practices. It's because it only takes one little thing. With that, shameless plug, you can view more on my blog. Again, the spec tool is on my blog as well. If you enjoyed the presentation, please shoot a tweet to MuleDev and say, hey, this was awesome. If you're like, holy crap, this guy sucked, why'd we waste our time? I give bribes. It's a horrible joke. And last but not least, this is the book. There's a lot of stuff, and we talk about a lot of stuff, and there are questions about hypermedia, questions about OAuth, what are the differences. Unfortunately, I don't have time to go through all the stuff. You can download this for free. It's 200 pages. This isn't a shield. This isn't a, hey, use MuleSoft. This is how to design a good API. You can get the book free at mulesoft.com/resbook. With that, are there any questions? All right, then I'm going to shut up and let you guys go home. All right, thank you.